10B, problem number 17. One of the following numbers is not divisible by any prime number less than 10. Which is it? A, 2 to the 606 minus 1, B, 2 to the 606 plus 1, C, 2 to the 607 minus 1, D, 2 to the 607 plus 1, E, 2 to the 607 plus 3 to the 607. Okay, so there are 4 prime numbers less than 10, 2, 3, 5, and 7. So we have to check for divisibility by basically all of them. First off, by a single glance at the problem, it's clear all of these choices are odd because they're all a power of 2 added on to something that is odd. So 2 is already off. These are all not divisible by 2. Okay, what about divisibility by 3? Well, we have to figure out how powers of 2 behave in terms of modular 3. So if we look 2, 4, 8, 16, 32, right? As we go up like this, right? This is 2 to the 1, 2 to the 2, 2 to the 3, and so on. And if we take it in mod 3, we get 2, 1, 2, 1, 2, and it actually repeats like this, right? So basically, what we figure out is that for even exponents of 2, it's 1 in mod 3, and for odd exponents of 2, it is 2 in mod 3. So basically, odd exponent gives 2 in mod 3, even exponent gives 1 in mod 3. And now we can use that to further reduce our problems, right? So like this is 2 to the 606. Well, we know that that's 1. 1 minus 1, that's 0. So therefore, this choice is divisible by 3. But this one isn't. This one is 1 plus 1, which is 2 in mod 3. 2 to the 607 minus 1. Well, 2 to the 607, as we talked about, that is 2 in mod 3 minus 1. That's not divisible by 3, but this one is. 2 plus 1 is divisible by 3. So that one's already out. So A and D are already out. And if we try E, notice this number is not divisible by 3 and this number is, so it's definitely not divisible by 3, which means that after removing all the numbers that are divisible by 3, we are left with 3 choices and divisibility by 5 left. So now how do powers of 2 behave in modular 5? Well, let's write down our numbers again. 2, 4, 8, 16, 32, 64, 128, 256. And if we just take in modular 5, right, we notice that there's this pattern, right? 2, 4, 8, 6, 2, 4, 8, 6, right? And because whether or not a number is a multiple of 5 or not just depends on the last digit, we know that this repeating pattern of 4, 2, 4, 8, 6, 2, 4, 8, 6 just determines the modulars. It just goes 2, 4, 3, 1, 2, 4, 3, 1, right? So basically 1, 2, 3, 4, 5, 6, 7, 8 are the exponents. So basically, if the exponent is 1 in mod 4, then that gives us 2 in mod 5. If it's 2 in mod 4, then that gives us 4 in mod 5. If it's 3 in mod 4, then it gives us 3 in mod 5. And if it's 4, or in other words, 0 in mod 4, it gives us 1 in mod 5. So let's erase all this and let's look back at these choices right here. The thing is, E will also need to look at we'll also need to look at the 3 to the 607 term, because this isn't just a 2 to the 607 term, we're also adding on a power of 3. So we'll have to take that into account. But first we can use it on these two, what these 4 say. And also on this term. But once again, we need to do something else for this term. But basically 2 to the 606, well, 606, that is 2 in mod 4, which gives us 4. 4 plus 1 is 5. So this is actually divisible by 5. So this is out. But 2 to the 607, that's 3 in mod 4. So we get 3 minus 1, which is 2 in mod 5. So C is staying. And now finally for E, once again, so we need to do the same thing, but for powers of 3, right? So if we take powers of 3, we go 3, 9, 27, 81, 243, right? And once again, we notice another pattern of last digits, but this time instead of like the previous one, which was 2, 4, 8, 6, this one's going in odd, of course, 3, 9, 7, 1. And if we take those in mod 5, then we get 3, 4, 2, 1. So basically it's the same chart, but different numbers, 3, 4, 2, 1. So it's the same as 2, except that these two are swapped. But the reason why that's of concern is because 607, the power of 607, that is 3 in mod 4. So if we look at the 3 in mod 4 case, 2 to the 607 is 3 in mod 5, and 3 to the 607 is 2 in mod 5. So in total, it would add up to 0 in mod 5. So this is divisible by 5, Therefore, E is out. And without even needing to check divisibility by 7, we know that our answer is C.